All right, so we're going to do some of those same problems again, going backwards and finding out X value, but this time we are going to use the TI-84. Okay, so I've norm command on your TI-84 plus returns the value from a normal population with an area given to the left. So unfortunately, the image that they had marked it wrong, but this is the one we're looking for. So I and V norm. So this is going backwards. This is always going to give you, you need to find an area to the left. This command takes 3 values as its input. The first is the area to the left. So we still need to find that area to the left. And sometimes it depends on the TI-84 you have. Sometimes they'll actually give you a choice of picking left, right, or middle. But for right now, we're just going to stick with left, just in case you don't have this. The second and third values are going to be your mean, and they're going to be your standard deviation. All right, so we're going to get to this the same way as we got to normal CDF, is that we're going to end up going to our distribution. So we do second bars. So this is a problem that we had done earlier. So we were trying to figure out if we had a mean IQ score of 100 and a standard deviation of 15, what score marks the upper 2% from the lower 82%. So what we needed was this area to the left, which was my 0.98. So we're going to need that, and we needed your mean and your standard deviation. So when you enter in your inf norm, going backwards, you need to, like I said, have that area, that mean, and that standard deviation. So let me show you this with actually the TI-84. Okay, so these are the 2 questions we had last time as far as those IQs went. Like I said, what score separates the upper 2% from the lower 98%? So we're looking for this value here that separates the 2% I have up here, and then the 0.98 that I have below that score. So we are going to go to second bars. Let me make this a little smaller. I'll get rid of the add. So like I said, second bars, you're going to go down to number 3, because that one's going to deal with, it's basically inverting the normal curve, going backwards. So like I said, sometimes you might see this. We're just going to do this all left for right now. Like I said, and that's just in case you don't have this feature on your TI-84 or whatever versions of applets or anything else we're using for a TI-84. So that area to the left, so to the left of the score is the 0.98. My mean, I have a mean IQ of 100 and a standard deviation of 15. Like I said, I'm going to keep it left tail for now. And we're going to get that X is roughly 130.8. So that IQ is going to be about what we had last time, is 130.8. So let me do that again. So if you do have that feature, if you do second bars to your distribution, number 3, if you can change the tail, that's telling you about the area. So the area that we also have to the right is 0.02, same mean, same standard deviation. If we go to the right, it's area to the right. And then we go to paste. You see that we still get that same X value back. So like I said, that's just in case you do have that feature. Not every TI-4 does. So for my second one, we want to find that score that is going to, the score that separates my middle 90% from what's in my tails. So like I said, 5% or 10% is left in the tails, 5% in each tail. So we have 0.05, 0.05. So we're looking for an X1 and an X2. So assuming you do this all left tail, So if we just did a left area, that means x1, we're just looking for that 0.05 is to the left. And then for x2, I made that a lot bigger. What we have here is the 0.9 plus the 0.05 that's left in that tail. So these tails together, this area is 0.95. And that would be my area that is to the left. So you'd have to figure out those two areas. You go to second vars again, go to number 3. My mean and standard deviation is the same, so I'm not fiddling with that. But I'm going to put in my 0.05. And like I said, we're doing this all as left tail. I'm going to show you what to do with the center tail in a second. But if you can only do left tail, this is what we do. That's approximately what we had before. This is going to be 75.33. We'll do 0.3 since I did only 0.1 decimal place here. If I want my x2, second bars, go to number 3. The area that is to the left of my z2 is going to be my 0.95. So like I said, all to the left. And once again, we're getting approximately 124.7. Now, if you do have that feature that does the middle, sorry, that's the wrong one. There we go. Sorry, I ended up in the wrong thing for a second. Go down to number 3. If you want to do just this 90 in the center, then you just put in your 0.9. My mean of 100, my standard deviation of 15, because I quit everything, I did that. And then looking for that center. As you see, it's going to give me those 2 scores. So like I said, we're going to do this all left because everybody's TI-84 should at least be able to do the left, or even if you had TI-83. But not everybody has that chance of doing to the right or doing to the center. All right, we're going to do one more example, or 2 more examples actually. Okay, so we're going to all do this with left area again. I'm just going to do solely just left. So going back to the dogs again, we had this question before with using the table. Was what age separates the bottom 5% of lifespan of dogs? So we're looking for X, and we want this to be the bottom 5%. So that is what we're looking for. So that's our area to the left. B is what age separates the top 15%. So this up here, for whatever the X value is, should be 0.15. That means that the area I need for my calculator is here. So it'd be that 1 minus my 0.15. Oops. It's just 0.15. So it's going to be 0.85. And then for C, I'm going to draw a couple little pictures for C here. C is that middle 95%. So we need 2 areas for that. And I'm going to bring them over here. So we'll continue C. So here we need that X1 and that X2. So if I just do to the left, as we said before, if we have 1 minus 0.95 is going to leave me with 0.05. That's both tails. So if I cut that in half, I have 0.025, which is where I get that bottom 2.25 or 2.5%. We'd have 0.025 here. That's my X1. X2 is we have the 95 that's in the center. And then we have this 0.0025 over here. So this whole area here is 0.975. I bring up my calculator again. Clear this all out. So for A, we already have the area to the left, second bars. So the area, so we're looking for that bottom 5%. So the area to the right, sorry, area to the left, we're just doing left, is 0.05. The mean lifespan of a dog is 13.42. And the mean is 2.36. So if I just do all left, like I said, some of you, that's all you can handle. My annotation device was not coming up. That means that my score here is going to be 9.54. So we'll just round out 2 places here. If I wanted this upper 15%, the age that splits the upper 15% ages of dogs, well, to the left of that is going to be 85. Second bars, number 3, area is going to be 0.85. Same mean, same standard deviation. Like I said, we're just doing left, nothing else. That is going to give me 15.87. And then if I wanted to figure out that 95% in the center, so what ages block off the 95% of lifespan of dogs exactly in the center of the distribution? That means I have to figure out what is left of X1. So we said what's left of X1 is going to be my 0.025. That is going to be 8.79. And then if I want my X2, that's the area is to the left of X2. We said is that going to be that 95% in the middle, plus that 0.025, sorry, that 0.95 in the middle, and the 0.025 in the tail. Combined, that is 0.975. So we're going to go second bars, number 3. And that area is going to be 0.975. Same mean, same standard deviation. Like I said, we're just doing to the left. And that's going to give me that 18.05. So it's approximately like we were getting with the Z tables. All right, so this one's just practicing with a bunch of different examples. So a normal, there we go. There we go. A normal population has a mean age of 3 and a standard deviation of, has a mean of 3 and a standard deviation of 2.6. We don't find the value that represents 80% below it. So this is X. That's definitely not 80%. This side, 80% below whatever X is. That'd be 0.8 here. And then, like we said, the mean is 3 and the standard deviation is 2.6. We're going to figure out what X is. Here, a normal population has a mean of 53 and a standard deviation of 34. We want to find the value that has 35% above it. So that means we're going to have a value, and what should be above it is going to be that 35%. So 0.35 is that area above. And my mean is 53, and my standard deviation is 34. Here we have a population has a mean of 3 and a standard deviation, again, of 2.6. We want to figure out what the 80th percentile is. So if you remember percentiles, that marks the boundary of 80, what the percentile below and what's left over above. So if I'm looking for the 80th percentile, really, this is the same question as this one. 80th percentile is asking you for this 80%. So once we find it here, we're going to find it here. So it's just introduce percentiles again. And then my last one, We're going to have some that's normally distributed. It's going to have a mean of 27 and a standard deviation of 12. And we want to find the values that separate the middle 60% of the population from the rest. Okay, so we're going to just go back and find all this information. So let's go back to the TI-84. And we'll go through how to do this very quickly. Okay, so my first question is a lot easier to deal with because we already have the area to the left. So if I do my second vars, I do number 3. I'm going to put in an area of 0.8. That's my area to the left. My standard deviation, no, my mean is 3, and my standard deviation is 2.6. And we're only doing to the left, so we're fair for everybody. The value for X would be 5.19. That means for this one, because it was 80th percentile, it's the same problem. This one would also be 5.18, or sorry, 19. Okay, so this problem here, where we're looking for the upper 35%, well, if I need my area to the left, this is going to be 1 minus 0.35. So this would be 0.65 over here. That is the area that is to the left. So second vars, number 3, we're going to put in 0.65. Our mean now is 53, and my standard deviation is 34. We're still just doing to the left. And what we get is that X, in this case, would have to be 66.10. Then for my very last one here, we're looking at 60% in the center. So we need to figure out what area is to the left of X1. And we need to figure out what area is to the left of X2. So if we're taking out that 60 in the center, and the two tails combined, what we're going to have is 1 minus 0.6. So that's going to be 0.4, which means in each individual tail, we're going to have half of that in each tail. So that's going to be my 0.2. So we have 20% in each tail. So here we know that's 0.2. We know here is 0.2. So another way you could think about how you're going to find this area is you could go 0.6 plus 0.2, or you can do 1 minus 0.2, which is 0.8. We do second vars. We go to the third choice. And for X1, my area is 0.2. My mean for this distribution is 27. Its standard deviation is 12. And what we're getting is that X1 would have to be 16.90. For X2, only thing it changes is now we're looking at the area to the left of X2, which happens to be 0.8. We're just going to say that X2 is going to be 37.1. We round out.